Hi students, welcome to Future Doctor NEET Academy for the problem solving session. Topic today is chapter 5 Magnetism and Matter. 7 questions already floated in a YouTube, and now we are going to discuss the solution, that is how to solve the problem for that 7 questions in this chapter. First question: a wire of length L meter carrying a current of I ampere is bent in the form of a circle. Its magnetic moment is dash. I think some of you found the answer. Which option is correct? Is it option D? Okay, let's check option D is correct or not. Wire of length L meter carrying a current of I ampere is bent in the form of circle. Its magnetic moment. There is a relation between magnetic moment and the current. What is the formula? Magnetic moment M equal to I into A. Wait, I'll take another color. Magnetic moment M equal to I into A. And A is the area and it's bent to the form of circle. So what is the area of a circle? A equal to pi r square. A equal to pi r square. And L length of the wire is bent to the form of circle. So what is the relation between L and R means? L equal to 2 pi R. 2 pi into R. From that R equal to L by 2 pi. L by 2 pi. Then R equal to L by 2 pi. Substitute here. That is M equal to I into pi r square. There pi into R is L by 2 pi. So L square by 4 pi square. This pi square getting cancelled. Then M equal to I L square by 4 pi. M equal to I into, for A only we substituted, pi into R is L square by 4 pi square getting cancelled here. Then M equal to I L square by 4 pi. That is option D. Option D is the correct answer. Let's move to second question. A bar magnet is hung by a thin cotton thread in a uniform horizontal magnetic field and is in equilibrium state. The energy required to rotate it by 60 degrees is W. Now the torque required to keep the magnet in this new position is dash. What's the formula for torque? Torque tau equal to M cross B. M cross B, that is equal to A cross B equal to AB sin theta. Same like that, M cross B, MB sin theta. MB sin theta. Then what is the relation between MB and energy or work? That is W equal to MB cos theta 1 minus MB cos theta 2. That is MB cos theta 1 minus cos theta 2. That is, a bar magnet is rotate from 0 degree to 60 degree. So theta 1 equal to 0 and theta 2 equal to 60. Then W equal to MB cos 0 minus cos 60 degree. Cos 0 is 1. Cos 60, 1 by 2. Then W equal to MB 1 minus 1 by 2. 1 minus 1 by 2 is 1 by 2. Then W equal to MB by 2. W equal to MB by 2. Then MB equal to W equal to MB by 2. MB equal to 2W. MB equal to 2W. Then substitute this MB equal to 2W here. Tau equal to mb is 2w sine 60 sine 60. What's the value of sine 60 degree? Root 3 by 2. Then tau equal to 2w into root 3 by 2. This 2 getting cancelled. So w root 3 or root 3 w. Root 3 w. Root 3 w, that is option B. Option B is the correct answer. Let's move to third question. A bar magnet of length L and magnetic dipole moment capital M is bent in the form of an arc as shown in figure. The new magnetic dipole moment will be dash. That's before bending, when it is in straight. At that time, what's the magnetic moment? What's the relation between magnetic moment and pole strength? Previously, we have discussed magnetic moment with the current, that is M equal to I into A. Now here, magnet means pole strength small m. So pole strength M equal to M into L. M is a pole strength, small m is a pole strength, capital M is a magnetic moment, L is a length of the magnet. So when this is in straight word, then at that time M equal to M into L. And when it is bent in the form of an arc of radius R, as shown in this figure, then its magnetic moment M dash equal to M into R. This radius of an arc R. Then what is the relation between R and L? You know the formula, length of an arc equal to angle into radius. That is, length of an arc is given small l only, so we'll use small l. L equal to angle is theta into radius. Theta is given as 60 degree. Degree you want to convert into SI unit. What's the SI unit of angle? SI unit of angle is radian. What's the relation between degree and radian? Pi radian equal to 180 degree. Then 180 degree equal to pi. And 1 degree equal to pi by 180. Then 60 degree equal to pi by 180 into 16. 60 by 180 getting cancelled, pi by 3. So directly I am writing, then L equal to pi by 3 into R. From that R equal to, because you are going to substitute this R only here. L equal to pi by 3 R. R equal to, come on, R equal to 3 L by pi. So R equal to 3 L by pi. Substitute this R equal to 3 L by pi here. Then M dash equal to M into 3 L by pi. 3 by pi take outside. Then M dash is equal to 3 by pi into M into L. We know M into L equal to capital M, that is a magnetic moment. Substitute this here. Then this is equal to 3 by pi into capital M, that is M dash. So M dash equal to 3 by pi of M, that is option B is the correct answer. Okay, let's move to next question. Fourth question. A bar magnet of magnetic moment capital M is placed in a magnetic field of induction B. The torque on it is dash. Option A, M cross B. B option minus M cross B. C option M cross B. D option minus M cross B. This I think C is the correct answer because I displayed in black color. Here one thing you want to note down, MB only in block letter. What does that indicate? That is other things not in block, and M and B only in block letter, block font. Why? That represents vector. Actually, we can represent vector in two ways. One is by giving block letters, that is in printed matter we will do. And while writing, we will use vector as arrow mark, M cross B. M cross B. So you can write as M cross B as bold letter M cross B. It means vector R. M vector cross B vector. And question is torque on it is dash. Tau equal to, you know the formula, tau equal to M cross B or MB sin theta. Tau equal to m cross b or mb sin theta. So tau equal to m cross b only. Tau equal to m cross b, and can you say tau? Torque. Torque is tau. That is a vector quantity or scalar quantity. Is it scalar? No, vector. Tau also vector only. So tau equal to m cross b, that is torque equal to m cross b or mb sin theta. Option C is the correct answer. Next question. Question number 5. At a point A on the Earth's surface, the angle of dip del equal to plus 25 degree. At a point B on the Earth's surface, the angle of dip del equal to minus 25 degree. We can interpret that. Actually, what is del? Del is a dip. Dip is what is dip? It is an angle. Dip is an angle between the horizontal component of Earth's magnetic field and the total magnetic field. And if del is positive, you can say blindly it is north. Point is located in the northern hemisphere. And if del is negative, it is in southern hemisphere. Come on, see. At a point A, del value is plus 25 degree. So that is northern hemisphere. And at point B, that is delta is minus 25 degree. That is southern hemisphere. So which option is correct? Yes, option A only. Sorry, option B. That is A is located in the northern hemisphere and B is located in the southern hemisphere. Option B is correct because A is in A only, delta is positive and B del is negative. Let's move to sixth question. A vibration magnetometer placed in magnetic meridian as a small bore magnet. The magnet executes oscillation with a time period of 2 seconds in the Earth's horizontal magnetic field of 24 microtesla. When a horizontal field of 18 microtesla is produced opposite to the Earth's field by placing a current carrying wire, the new time period of a magnet will be dash. What is the formula? Time period T equal to 2 pi into square root of I by m d. This is the formula. And here I, m and all constant, only b is variable. And b is represented as bh. So that is bh. From this, t is proportional to 1 by root of bh. 1 by square root of bh. So T1 is proportional to BH1 and T2 is proportional to BH2. Then T2 by T1 equal to T2 by T1 equal to BH1 by BH2. BH1 by BH2, that is square root. And BH1 is given 24 microtesla. That is 24 into 10 power minus 6 divided by BH2 18 microtesla. 18 into 10 power minus 6. 10 power minus 6, 10 power minus 6 getting cancelled. And 6, 4, 24, 6, 3, 18. So 4 by 3. T2 by T1 equal to 4 by 3. T2 by T1 equal to 4 by 3. T2 equal to 4 by 3 into T1. T1 is given T2. Sorry, square root of 4. No, square root of 4 is 2. Yes, this is square root. So this will be square root. So this is equal to 2 by root 3. From this, T2 equal to 2 into 2, 4. So 4 divided by root 3. 4 by root 3, that is 4 by 1.732. That value will be 2.3. 2.3. 2.3 is approximately 2 seconds. So option B is the correct answer. Let's move to last problem. According to Curie's law, the magnetic susceptibility of a paramagnetic substance at an absolute temperature T is proportional to dash. Susceptibility is denoted by a symbol chi. And chi and T, that is when temperature increases, chi decreases. When temperature decreases, chi value increases. So chi is inversely proportional to temperature T. Susceptibility is inversely proportional to T. So which option is correct? 1 by T. Option C, 1 by T is the correct answer. Okay. Thank you. Thank you, students. Same way, in next session, we are going to give 7 questions in the next chapter, electromagnetic induction chapter. Okay. Thank you. Thank you very much.